Hi, ladies and gentlemen. We are looking at notes or section 10.2, which is on linear functions, and we're going to fill out the video notes right now. Before we get into linear functions specifically, let's define what an actual function is. So just a reminder, a function is a relation in which each input has only one output. If an input has more than one output, it is not a function. So let's take a look at our examples that we have here. All right, so our first example says 2, 5, negative 3, 7, and 1, 5. And remember, our x's are our inputs, and our y's are our outputs. So each input here has only one output, so it is a function. So we're going to say this is a function. Because each input has only one output. Okay, all right, so now let's take a look at example 2. Example 2 has negative 5, 1, 4, 8, and 4, negative 2. And if you look, this 4 has an output of 8 and an output of negative 2, which means this is not a function. So we're going to say no, an input has more than one output. All right, so now let's look back at what the vertical line test is saying. So it will tell you if a function is if a relation is a function or not. And it says a relation is a function if there are no vertical lines that intersect the graph at more than one point. So our first example that we have right here, any vertical line I draw will only intersect my graph at one point each. Okay, so 1 point, 1 point, 1 point. Any line I draw, no matter where I draw it, will only intersect my graph once. So this is a function because it passes the vertical line test. All right. So now if I were to look at this one right here, no matter, even though here I have one point that intersects, here I have a vertical line that intersects more than once. Even if I have just one, it is not a function. So we'll say no. It does not pass or it fails the vertical line test. Okay? All right, so now we can take a look at information about linear functions. So there are 3 different things that you will see on your paper. The format of a linear function is always in the form y equals mx plus b, which you all know. M is your slope, but I want you guys to write down that it's a rate. And it's always going to be a unit per unit, and B is your y-intercept or your starting amount, okay? But it's all defined right here for you as well. So the slope is represented by M, and it is a rate. It's always a unit per unit, so miles per hour, gallons per minute, anything like that would be considered a unit. And then you could find the slope by either doing rise over run, the change in y over the change in x, remember delta means change, or you could do y2 minus y1 over x2 minus x1. All of this is stuff you guys already know, okay? And then the y-intercept is represented by b, and it indicates the initial value, and it only happens when x is equal to 0, all right? So let's take a look at a couple examples that we have here. So our first example that we see is example number 1. And it says you join a gym that charges $50 to join and $25 per month. So since this is $25 per month, that's your slope. So we're going to say M equals $25 per month, and it charges $50 to join. So your initial amount, your beginning amount is 50. So that means that your equation is simply y equals 25x plus 50. Which should make sense to you because you would do 25 times the number of months plus $50 to join, okay? All right, so now let's take a look at example number 2. Example 2 is a little trickier. You join a gym that charges $25 per month. So you know the M, it's $25 per month. And then you know that you pay $100 after 2 months. So your starting amount, you do not know, okay? However, you do know that you can say y equals 25x plus b, and this $100 after 2 months can be written as a coordinate. Your independent variable which is time, is 2 months, and your dependent variable, which is money, is $100, right? If it's $25, this is the Y. Per month, this is the X. So our X is months, our Y is time. So I'm going to just plug in my information. So I say Y, or 100, excuse me, will be plugged in for Y, equals 25 times 2 plus B. So I'm going to say 100 equals 50 plus B. So subtract 50 from both sides, you get 50 equals B. So that is your starting amount. $50 is your starting amount. B is no longer a mystery. B equals 50. So we can say that our final equation is Y equals 25X plus 50. All right. And then lastly, example number 3. You go to a gym that charges $100 after 2 months and $200 after 6 months. So again, we don't know the slope this time or the y-intercept. Both of those are unknown pieces of information. But remember, your slope is going to be in terms of dollars per month. So your dollars are your y value, your month is your x value. So if I were to write this out, this is y, this is x. So my coordinate would be 2, 100, and my second coordinate would be 6, 200. Okay, so then I would just say m equals, I just plug it into the slope formula. So m equals y2 minus y1 over x2 minus x1. My y2 is 200 because it's my second y. My y1 is 100 over 6 minus 2 because this is my x2 and my x1. So you get 100 over 4, which means that you end up getting 25. However, you gotta tell me it's 25 what? What's the unit? $25 per month. Okay, so that's what we got for our m value. Now we need to figure out what our b value is. So same thing that we did before, we're just gonna do y equals 25x plus b. And let's use our coordinate 2, 100 again. So let's plug it in. Just like we did before, you should get the same answer, but just so you can see how this works. So 100 equals 25 times 2 plus b. So you get 100 equals 50 plus b, right? So then subtract 50 from both sides. 50 equals b. So your answer here again is y equals 25x plus 50. All right, so let's take a look at the next page about comparing functions. It says 3 different linear functions. It should be 4 different linear functions are represented in 4 different ways as shown. So if you look right here, our first function is shown in a table, our second is shown in a graph, our third is shown in an equation, and our fourth is shown in a description. So let's figure out how to do all of this stuff right here. So question A says, which function has the greatest rate of change? So that's our m, our slope. That's what we want to figure out. So let's figure out the slope of function number 1. So in function number 1, right here, we have our slope, or we have 2 points that we can choose from. It's up to you what 2 points you want to choose. So you can choose -3, -9, 3, 3, or 6, 9. What I'm going to do is I'm going to choose 3, 3, and 6, 9 because those are positive values and I don't want to have to deal with any negatives. So function number 1, we're going to say m equals 9, or let's write out our coordinates. So 3, 3, and 6, 9. So our y2 is 9, our y1 is 3. So I would do 9 minus 3. Our x2 is 6, and our x1 is 3. So I would do over 6 minus 3. So I would get m equals 6 over 2, or excuse me, 6 over 3, which means that your slope right here is 2. So I'm going to write down right here that our slope for function number 1 is 2. Our rate of change is 2. Okay? Now let's figure out our rate of change for function number 2. So for function number 2, I'm going to do rise over run because it is a graph. So let's figure this out. Rise over run. Here's a starting point. Here's an ending point. It went up by 3 and it went to the right by 2. So it's, I could also say delta y over delta x because it means the same thing. So y is changing or going up by 3. And it's going over by 2, so that's my slope of this line right here. So m here equals 3 over 2, or remember 3 over 2 just means 1.5, okay? All right, so now let's figure it out for number 3. Function number 3 is in an equation format. So in order to be able to figure out what the slope of function number 3 is, I just have to isolate y. So I'm going to subtract 3 from both sides, and I end up getting 2y equals 3x minus 3. And then I would divide everything by 2. So that means that y equals 3 over 2 x minus 3 over 2. So that means that the slope of this function right here is also 3 over 2, okay? And then our fourth representation is in an equation, or is in a verbal description. It says y is, so I'm going to say y equals 4 less than a number, and we'll call that number x. So we'll say y is equal to x minus 4. So here our slope is 1. So our end right here is equal to 1. So then it says which function has the greatest rate of change? Well, which one of these numbers is biggest? 2, 1.5, 1.5, or 1? The answer should be 2. So right here we would say that function number 1 is our final answer. And then when it says to justify our answer, we've already justified it by showing all of our work. Okay? And then part B says, does any pair of functions have the same rate of change? Well, if you guys look at this right here, we got 3 over 2 for function number 2 and function number 3. So our answer to this would be yes, functions 2 and 3 both have a rate of change of 3 over 2. Okay, and we've already justified our answer again because we've shown our work on our paper right here. Okay, I hope you have a wonderful day.